Welcome to the Crazy High Chemist. So another video in gases. Bam! So today we're talking about Charles' law. And there's a picture of Charles. He was a French scientist, Jacques Charles. Okay? The volume of a fixed amount of gas at constant pressure is directly proportional to the absolute temperature of a gas. So you get this relationship, which is volume is proportional to temperature. Okay, so look at that combined or the general gas law right there. And what is being held constant? It says it right there, constant pressure. So what I want you to do is erase the pressure terms right there, and then you're going to get Charles' law. So this is fantastic. I want you to rekindle in your mind there that we just talked about Boyle's law. We used the combined gas law and we held what constant? The temperature constant, and we got Boyle's law. Now we're doing Charles' law and we're holding the pressure constant, and we use the same general or combined gas law. That is super cool. So we got the general or combined gas law, we got Boyle's law, we got Charles' law. It's like one equation for 3 different times. That doesn't get any better than that. In fact, it does in the next set of videos. Okay, so there's this graphic here, and if you ever do this in your laboratory, which is a super easy experiment, and it's a great experiment to do, okay, but you should get this kind of graph when you're doing this. And what you're doing on the right hand side of this here, we got temperature on the x-axis, volume on the y-axis, and on the right hand side of this graph I have helium and I have methane. And you should be able to get some values on the right hand side of this graph. And what you end up doing experimentally is extrapolating those volume and temperatures until you hit the x-axis. And it's really interesting that it doesn't matter which gas you use or which set of gases that you use, you always come up with this same temperature. So the question is, what is that temperature? So take a look at that value right over there and think to yourself, what temperature should that be? Yes, of course, it is absolute zero, which is 0 Kelvin or negative 273.15 Kelvin. Okay, note, just so that you note, gases never reach this temperature because they either liquefy or solidify before reaching this temperature, but theoretically that's what Charles' law does. Okay, and you should see that as the volume goes up, the temperature goes up, or as the temperature goes down, the volume goes down. That you can see graphically using that graph. Super great graph. You need to be looking at the graphs. Okay, here's another example here. You should see with this graph, on the x-axis we have temperature, on the y-axis we have volume. You should see that when that piston is pushed all the way down, we have low volume and low temperature, right? As that piston is moved up, we have increased temperature and increased volume. And those gas molecules are moving faster. They have higher kinetic energy. All right, so take a look at that graph there as well and those diagrams. Another example is like a balloon. Okay, notice that these balloons at the bottom, imagine the balloons at the bottom are tied up. Okay, and if you heat those balloons, they will increase in volume and expand. If you cool down those balloons, they will decrease in volume and contract. A really super cool experiment to do, and you can check this out on any YouTube video of some kind. Not mine, unfortunately, because I didn't bring it with me here today. But look up liquid nitrogen and balloons. So if you take liquid nitrogen, you blow up a balloon with any gas, and you put that balloon in liquid nitrogen, that balloon will contract. That means that the gas molecules are cooling down and they're decreasing in volume in between the gas molecules, and that balloon will get smaller and shrink. And then if you take that balloon out of the liquid nitrogen, then the gas molecules will warm up and they're moving faster, and then it will increase in volume. Super cool that you can do that. Okay, the other really cool thing that you can do in a chemistry lab or in any lab, and you can actually maybe do this at home, I don't know, but if you were to take an aluminum can, we're going to take a crush can on purpose. Okay, you can only use crush cans, of course, right? So you're going to take an aluminum can, empty it out completely, drink its contents, okay? Hopefully it's just a soft drink or something like that, okay? Now fill up the bottom of the can with a little bit of water. Heat that water up inside the can so that it is boiling, okay? And then on the side, you need to have a cool pool of water. Maybe some ice water really works best. And then you're going to take that can that has just a little bit of water inside of it, and you're heating up the gas, the liquid in there, you're heating up to the gaseous state. The whole can is now filled up with gaseous water. It's boiling. Now take that can with some tongs and flip it upside down so that you close off the open end of the can in the cool water. And what will happen is all the gas molecules that are inside the can will now condense to the liquid state. And there's a huge volume difference between the gaseous state and the liquid state. The gaseous state is filling up the entire can. The liquid state is small little tiny molecules that are droplets and much, much smaller volume. And what will happen, the can will actually collapse on itself. It will collapse on itself because the outside pressure is much greater than the inside pressure at that point in time. Same thing would happen if you didn't dive using a diving bell underneath the ocean, because there's a tremendous amount of pressure and you just collapse. Okay, super cool experiment to do. You should be able to do that in your chemistry lab as well. Now, just like with Boyle's law, you're going to make a prediction. So you need to ask yourself, what is being held constant in Charles' law? Okay, so if the pressure is being held constant, we're going to rotate at this point right here. So as the volume goes up, the temperature goes up. Or alternatively, okay, as the volume goes down, the temperature goes down, because you're rotating at the pressure point. Hopefully that makes sense. Put your finger through that pressure point, either rotate up, the volume and temperature are proportional, or rotate down, the volume and temperature are proportional. Note that for the next problem, the next video that you watch using a Charles law application. All right. I am the Crazy Hat Chemist, and I am wearing a crazy hat. It's not really a super cool crazy hat, but Elise, thank you very much for this hat, and thank your father also for this hat. Love you guys. Thank you very much. Give me a thumbs up if you like that video. Subscribe to my YouTube channel. See you later. Bye now.